Hey, I'm Thomas and this is day 10 of 100 Days of Code in IoT Challenge. Today, I'm gonna continue on yesterday's project. So a quick reminder, I'm working on the time-controlled relay device based on ESP8266 and I'm making it send secure HTTPS request to AWS Lambda that is put behind API gateway. What I've done already is the actual web service that is hosted on AWS. I've done this deploying it using serverless framework, and I also extracted SSL certificate that is required to be used with BearSSL client on ESP8266. And now I'm going to modify the code on ESP8266 to work with HTTPS client instead of HTTP. Let's just move to the code. And now finally we can modify the sketch. We have everything that we need, which is essentially the hosted web service and the certificate. Okay, so first step is going to be a little refactoring with the way we connect to Wi-Fi network. So first of all, what I'm gonna do is to move these instructions that essentially they connect to, this code connects to Wi-Fi network, and I'm gonna move it to the function. Let me just make it a boolean, so it's gonna return true if the connection was successful and false otherwise. And I'm gonna call this function connect to Wi-Fi. I'm not returning anything yet. I'm gonna paste this, and for return, if we fail to connect, it's going to be false and true otherwise. Now I'm going to move it to the beginning. I'm gonna tell you what, in a second why this is going to be in the beginning. Yeah. And since I extracted it out from send HTTP request, I need to call the function in the body of send HTTP request function. Right, so that didn't change much. However, what else we want to do is after we connect, we're making all of those instructions to send the message, to send HTTP request, and at the end, I would like the Wi-Fi to be disconnected. That can be done with Wi-Fi.disconnect. Wi-Fi is a global static object that we can get access to by, I think, including ESP8266 Wi-Fi that gives you access to this. Okay, so what happens is when the send HTTP request is called, we connect to Wi-Fi, do all of those instructions, and disconnect from Wi-Fi. And the reason I'm disconnecting from Wi-Fi is because I would like to save power. Wi-Fi is quite power consuming on ESP8266, so essentially if this is not required to be used, which is for most of the time in this project, is not really. We just need it for sending a HTTP request. So that is the moment when I connect, and once the job is done, we disconnect. In the next step, I need to synchronize the time on the device. The reason I have to do that is because the SSL certificate that BearSSL client needs to verify has expiration time, and that needs to be checked against the actual time. On ESP8266, when the power is supplied, it starts counting the time from the 1st of January 1970. UTC time, this is basically the start of the Unix timestamp. In order to have the actual time on ESP, we need a Wi-Fi connection, internet connection, and the synchronization with the time server. And that is gonna be something I'm just gonna code. But to speed everything up, I'm going to go to Arduino IDE and open one of the examples. it is BearSSL set store. And what we need to locate is set clock function. I'm just gonna copy and paste it in here just above the setup. Right. So just quickly going through the code, it all starts with the config time. This function does the whole synchronization with the NTP servers. As you can see, the first argument that is required to be provided is the time zone in seconds. Then we have daylight offset and few, I think it's 2 or 3 NTP servers. Yeah, and this is quite important here. There is no way to tell when DST starts. This is partly true, and I'm going to explain in a second why just partly true. Right, so since it starts counting from 0 Unix timestamp, the now value that is basically assigned, this is the result from time function, and this is assigned to now variable. At the beginning, when the power is supplied to ESP, it is going to be very low value, right? It starts from 0 and just counts the seconds. So given that around 0 Unix timestamp is year 1970, and now we have 2020, what can happen is here, just by checking the now value, we can tell whether the time has been synchronized or not. And this is what happens here, right? So we started this process. This is asynchronous, so it's gonna happen eventually. And then this while waits until the time is synchronized, right? So it constantly checks for the now value, and if the now value is greater than 16 hours, so that's gonna be 4 p.m. Like, if the synchronization happens just at the start in the setup function, this is gonna be, around 4 p.m. January 1970 on the device. And then, it just checks until this is synchronized with, the actual date, 2021. And this is when it exits the while statement. And those lines are just used to print out the time in the human readable format, because now is essentially the number of seconds elapsed from the 1st of January 1970. So that's to print the time out. This is not really required, but I'm gonna keep it so we can see what is the actual time, right? We can get it in the serial monitor. This while loop, however, needs to stay here because we want to make sure the time is synchronized before the verification of the certificate starts. Right, and that is the reason why I have put set clock and connect to Wi-Fi at the beginning, because I need to call them in a setup function. And in PlatformIO, I think there is a certain flag that I need to run the compiler with. So the order of functions declaration won't matter, but at this point you have to put them before they are called. Okay, so what I'm gonna do now is, first of all, basically I need to connect to Wi-Fi in the setup function in order to be able to synchronize with the time server that is on the internet. So I'm just going to connect to Wi-Fi. Because it returns Boolean, I can make sure we are connected. And then when we are connected, I'm gonna call set clock. Right? If the connection fails, we're just gonna print out the information. Also, if it fails, there is no point in synchronizing the clock. I can introduce some variables later on, so we can skip the whole request sending. The whole request sending if the time couldn't be synchronized due to failed connection to Wi-Fi or something like that. But for now, let's just keep it like this. What we could do here to double check is I can synchronize the clock again in the same way. So we say this, but actually sort of other way around. So we say if it's not connected, we're just going to return. So that won't happen. And if it's connected, we're going to synchronize the time. That's gonna happen, if it's second time, that's just gonna happen immediately. I mean, this is just gonna, do all those operations. It's not even gonna enter the while loop because time will be already synchronized. So yeah, this is what is needed for the time synchronization. And now let's switch to the SSL client. To switch to the SSL client, what I'm gonna have to do is to use BearSSL, and there is Wi-Fi client secure instead of Wi-Fi client. So that's not required anymore. And that client, I think, does it require anything? No, it doesn't actually require anything in the constructor. So we're just statically creating an instance. And then to set the certificate, that is gonna be the certificate part, I need to call set. This is called, I don't think it's set, it's set trust anchors. This is the function to set the certificate. Yeah, be careful about those methods, that they can be quite misleading. Set CA certificate. These methods are deprecated as far as I know. These are compatible with the previous implementation. We're gonna use the trust anchors instead. And that one requires X509 list. I'm going to create it here. So that's BearSSL X list. I'm gonna call it list, and I think that list takes an argument in the constructor. Let me just make sure. Yeah, and this is gonna be either PEM certificate or DER certificate. Our format of certificate is PEM, and that's it. That requires char pointer. So there's gonna be, we're gonna need to copy paste it. So what I'm gonna do now is to open the certificate with Visual Studio Code, the one that we downloaded with Mozilla Firefox. So that's gonna be in my downloads directory. It is this one. So I'm gonna open it here. It's just a string. And this is something I'm gonna have to copy in my code. But first of all, I need to declare a const char pointer variable. I'm gonna call it cert, and this is gonna be stored in the program memory to save our RAM memory. This is quite long, so that's what I'm gonna do. And because that is quite long, the certificate, I'm going to use this that allows me to, one second, that allows me to, that needs to be EOF, and then, so that allows me to essentially paste the whole certificate in here. So the whole thing is going to be treated as C string. The REOF is like, in comparison with JavaScript, this is like backticks. So you can do backticks and in JavaScript, and it is very similar. Okay, so we got certificate that is stored in the program memory. So we save RAM. There is more program memory than the ROM memory than RAM on ESP. And this is something that needs to be provided to our list. So that's certificate. And then set trust anchors needs an address from the list, a pointer to list. Okay, So that's how we set up the BearSSL client. Let me just put it here in one section. Cool. And now I need to modify this address here. That's not going to be HTTP anymore and not a local address. So I'm going to again go to another VS Code window and copy this one. And then just paste it here. Okay, that's auto-formatted. Okay, so we're gonna be sending a request to API gateway instead of a HTTPS protocol, and thanks to BearSSL and the certificate that we set here, we should be able to do that. We can keep the same HTTP client since once you provide the Wi-Fi client, BearSSL Wi-Fi client is going to use HTTPS and do all the verification in there. Right. So not like this example. Let me just go back here. Just gonna show you something. So in this example here on the cert store, I'm gonna talk about cert store in another video. But essentially, if you look at this one, they make the manual. They just make the manual. They use the Bear client, the Bear Wi-Fi client, and they do the whole thing, the whole HTTP request manually. This is not. It doesn't need to be done in this way. You can keep using the standard HTTP client because internally, it's still gonna use all those functions on the client, like connect, and connect with BearSSL is going to verify the certificate. Cool. So that's it. That's it for the. Oh yeah, there's one more thing. There is one more thing, because since we disconnect from Wi-Fi here, we want to save battery. We disconnect here. We also want to disconnect in the setup function. So once we set the clock, we want to disconnect from Wi-Fi because we don't know when someone presses the button. So until that time, it's better to have Wi-Fi disconnected, right? So we save battery. And here, it's just gonna connect again. If it doesn't manage to connect, that's it. If it manages to connect, then we set the clock again. We make the whole thing, right? We make the request, and then it disconnects. Cool. Okay, so now I'm going to test it. So first of all, I'm going to compile it to check if I haven't done any errors. Okay, that was successful. And now I'm just going to deploy it. Okay, and in the meantime, I'm just going to put this window next to the logs from. Yeah, let me just show you everything on one screen. This one doesn't need to be like that. Yeah. Just refreshed it. So here is the log stream from the hello from IoT API dev hello Lambda. I think there's gonna be a new log stream, so I'm gonna keep this view in here. And again, this is gonna be something that we don't need. Yeah, like that. Let me just connect to the serial monitor. Oh yeah, we're quite late, so we couldn't see the synchronization message. Let me just restart. There is a restart button on ESP8266. So that's just gonna, start again, run the setup method and everything. The other way is essentially cut off the power and connect it back. But yeah, I'm just gonna press the restart button. So we should see the synchronization. So that's one thing. Yeah, we see like there's some weird stuff here, and then we can see That always happens. Like this always happens when you reset. And right after that, we can see waiting for NTP time sync. That's gonna take a few seconds. In the meantime, actually, I'm going to remove the log streams here, so we have this clean. Okay, there's no log streams. We're still waiting for NTP time sync. Yeah, sometimes it takes a while because generally you shouldn't be synchronizing your time with the time server more often than once in 30 minutes. And I'm doing it second time, so probably it's gonna take a little more time to synchronize. That takes quite a while. I'm probably gonna need to implement some sort of mechanism to set a time limit and restart the device and retry the synchronization. Oh, okay, that worked. Okay, so we got the current time, 1:24. This is cleaned up, so there is no log streams at the moment. I'm going to press the button. We should see the success message, and then we should see the log stream in here. Let's do it now. So I'm pressing the button, switching on the relay, switching off. We can hear the buzzer. Now it reconnects to Wi-Fi. And great. Yeah, that went well. Your function executed successfully. And now let's confirm with the CloudWatch. It's gonna take a second. Okay, we can see the log stream. I'm gonna open it. And that's what we got. Body message hello from ESP8266. So that worked. So that's the entire, that's what you need to do to make a secure request to an internet hosted web service. Of course, this code is not perfect. Let me just go back to this view. I'm not sure, but you probably noticed that the buzzer was on for more than 2 seconds. Those 3 dots in here tell us that it was 3 seconds, at least 3 seconds. They come from connect to Wi-Fi here. And because connect to Wi-Fi is a blocking operation, once we switched on the buzzer that is non-blocking, switch on the buzzer by doing digital write, this is non-blocking because it relies on the loop function. But the loop function cannot be executed until, cannot be executed again to check, if it's time to switch off the buzzer until this is not finished because of the delay function in here. So as long as this is correct sort of situation in the setup function, when we really want to make sure we are connected to Wi-Fi to set the clock, it is not sort of situation we would like to do in here. Right? We would like to do in here. So in order to change this, we're gonna have to refactor the code to be more event-based instead. But that's gonna be something that I'm gonna do in the next video. And this is it for today. Thank you very much for watching. If you are interested in this type of content, or you don't want to miss the next video when I will be refactoring the code to be more event-based, subscribe to my channel. If you have a question, suggestion, or feedback, leave the comment. Thanks, bye.